This runbook and network diagram were generated from raw show command output in about 10 minutes. No manual writing, no copy pasting into spreadsheets, 5 Python scripts, and 1 AI prompt, all of which I'm going to share with you for free at the end of the video. If you manage a network, you already know the problem. Documentation is always the thing that falls behind. Configurations change all the time, documents don't. And when something breaks at 2 a.m. and you're staring at part of your network that you have to remember how it's configured, this is a problem. I'm Garrett. I've been in IT for 11 years now, and I got tired of network documentation that was outdated before I even finished writing it. So I built a workflow to fix that. Here's what we're doing. We're going to collect live show commands from network devices, strip out anything sensitive so that it's safe to give to a public LLM. We're going to build a prompt, and then that prompt will generate us back an operationalized runbook. And I also have a small surprise at the end of the video for you. This includes 5 scripts, 1 workflow, and I'll link all of this to my GitHub in the description below. The GitHub includes everything you need to get started and run this in a lab today or in a production environment. It includes step-by-step instructions on how to install VM Workstation, how to install CML, both of which are free. Okay, so we'll switch to the collector script and I'll show you what this does. I'm running this against a small CML lab on my desktop, just running VM Workstation. I'll show you how to install all of these for free in a later video, but I'll also have a walkthrough on my GitHub so you can do it right now. The lab is just 2 routers and a switch. There's an access switch, a core router, and an edge router, all running Cisco iOS, all reachable from WSL. This uses Netmiko, which is the go-to Python library for SSH into network devices. These scripts work the same way, whether it's 3 devices or 30 devices. You just add entries into the device list, which is here, using the typical Netmiko format. I plan to put a video out about this later on how to set up Netmiko, but there's already some great resources on how to do this on the Netmiko GitHub repo from Kirk Byers. The role determines which show commands get run. Routers get routing commands, switches get VLAN and spanning tree commands. You can see the full command sets here. Here's your router commands that we're running. Here's the switch commands that we're running. Obviously, I'm familiar with all of these commands, but I did have a conversation with Claude to essentially help me put together the best show commands to generate the best type of runbook. So these aren't just random. I did do some research to figure out which commands will generate us the best documentation. These are the commands that you'd run during a health check anyway. The collector just runs them for you. So let's go ahead and run the first script. So I'll go ahead and activate my Python virtual environment here, and we will just call the first script. This is just admin and Cisco 123, which is documented on GitHub. No enable secret, but I built the code to ask for an enable secret just in case you do have one. And you'll see here it's just running through the show commands, and it's done. And the way this is built is this will just create an output file with the date and time that it was ran. So we'll go over here to our newest one. You can see here we have text files with the access switch, the core router, and the edge router. Keep in mind that these text files do have real raw data of which you do not want to feed to a public LLM. And that brings us to the most important part of this entire workflow, redaction. Before we go any further, let's talk about why this step exists. If you're using a public LLM like Claude, ChatGPT, Gemini, Copilot, you need to be careful about what you're sending. On a paid personal plan of these public LLMs, you can opt out of data training, and they say they'll honor that, but your data still hits their servers and gets retained for a certain period of time. Depending on your employer, you may have certain data privacy regulations that you have to follow, and this is a big no-no. The opt-out is a policy promise, not a contract. Enterprise agreements and API access give you contractual agreements, but if you're not there yet, using a redaction script like this is the next best thing. A good rule of thumb that I use when pasting data into a public LLM is that if this isn't something I would share on a public social media post, I shouldn't be putting it into an LLM. You have to think in terms of the attacker. Anything that you give to an LLM could potentially be compromised. And that can be used to build contextual information for your environment for an attacker to use against you. Your running configs have enable secrets, SNMP community strings, TACAX keys, line passwords. Your show output has real IP addresses, serial numbers, MAC addresses, host names. If you paste all that into a public LLM, that data is now outside of your control. Now, I don't say all this to scare you away. I just want to make sure that you're informed, and there's a better way to do it. You can do a lot of this processing locally so the data doesn't hit a public LLM, and that's exactly what this script does. So the Redactor will take that output folder that we just created, replaces sensitive data with placeholders. It handles 11 different categories. Credentials are always stripped. That's non-negotiable. But everything else is opt-in. So you can choose to redact certain things or not redact certain things depending on your organization's security policy. You can also just use the -- redact all flag to enable everything at once if you want. So let's go ahead and run that now. We'll do Python O2 Redactor, and then we're just going to call the input directory. And then we're going to add the redact all flag. And it would help if I called the right output path. I'll do this. There we go. And this will tell you everything that it redacted per text file. So on the access switch, it stripped out 2 credentials, port descriptions, VLAN names, serial numbers, host names, IPs, MACs, timestamps, and then this gives you a summary of everything that it redacted for all the text files in that folder. Let me quickly show you what one of these text files looks like from our initial collection script. So we'll just bring up the access switch. And again, this is just all the commands it ran. So this is a pretty lengthy file. And then I'll also bring up the redacted one. As you can see here, there's some placeholders, timestamp, version, serial, the IP addresses, MAC addresses, descriptions. There's lots of redacted info in here. It created this map.json file, which will be stored locally on your machine. And this essentially maps the placeholders with the IP addresses to fill back in later after you generate your AI prompt to build you your documentation. Your AI will work with these placeholders and will swap the real values back in later. One thing I want to point out, and this is an issue that I ran into when I was building this, is it will also pre-scan all the files for host names before processing. So for example, in a show CDP neighbor or show LLDP neighbor, instead of showing the actual host name of the device there, it'll get rid of that as well. Now we need to take those redacted files and run them through our prompt assembler so that we can give them to a public LLM. So we'll run Python input directory. We'll do our output directory. So the prompt assembler script will actually give you estimates on the number of tokens that it uses, the number of words that are used, and the total number of characters. Now, for 3 lab devices, we're looking at about 13,000 tokens, which you can easily paste into ChatGPT or Gemini. However, just a quick note, as you're probably already realizing, in a real environment, when you have more than 3 devices, this can quickly get out of hand in terms of the tokens and the context window that you'd be allowed to paste directly into a chat. If that happens, the API version of this workflow will handle it automatically. I'll cover that in the next video, but it essentially just talks directly to each device instead of building one flat text file. Once that video is done, I'll have a link to that up at the top of the video here. Here's the fun part. So we'll go ahead and open up a web browser, get to ChatGPT, and we're going to grab our file that has our prompt in it. I'm just going to Control A, Control C. Again, you could also just save this file and upload it as a file in ChatGPT here by doing upload photos and files. Paste this in here as plain text. And it looks like ChatGPT pastes as attachments automatically. That's pretty cool. And we'll let this run. So as you can see, this took about 2 minutes and it saved a file called runbook.md for me. We'll go ahead and download this and see what it looks like. All right, so full disclosure, I had to rerun this script using ChatGPT extended thinking, and it took about 6.5 minutes instead of 2 minutes for standard thinking. Reason being is it missed one of the devices. It missed device 3 here in the original inventory. AI will make mistakes sometimes, and that's why I hope to improve this in the future using the API that I'll be posting in the next video. So just keep an eye out for that. But you do have to keep in mind that when you are pasting into a public LLM, it's possible that it can have some non-deterministic outputs just because of the nature of how LLMs work. So that being said, here's our runbook. So you can see here we have our devices, the device inventory, our IP addressing, and again, all this is redacted output. So they're the port descriptions, the IP addresses, the host names, all the important stuff has been redacted for security purposes. So now I'm going to save this as a markdown file in our output folder. So get rid of this, pop this back open, refresh this guy. So I'll go ahead and save this runbook to our output folder under the timestamp section. This is what the script requires. So drag this guy over here. And pro tip for VS Code, if you just do Control-Shift-V on a markdown file, it'll convert it to a markdown preview. Now we're going to run this through our restore script. So this will take our map JSON file that we created earlier, combine it with the runbook that we just created, and put all of the useful information back into the runbook so that we have the host names and IP addresses that apply to our environment. We'll go back here. We're going to run Python or point it to our JSON file here, and we'll run this. Okay, so the file generated, we'll go over here to runbook restored, do Control-Shift-V. So yeah, so we have our topology overview. We have a device inventory list here. We have our IP addressing. So it says, on access switch 1, these are the interfaces. These are the port descriptions. If there are IP addresses assigned, it'll give you those. Same for the core router and the edge router. It gives you a routing summary. Again, I'll post all these on GitHub so you can view the output examples as well. Gives you a layer 2 summary of your VLANs, which management services are running. And then my favorite part is this findings and flags section. This will basically give you an overview of your total environment and make you aware to issues or configuration problems that you have, and something you should probably take a look at. Now, again, these are AI generated, so you want to make sure that you actually read through this and review this before pushing this documentation file into production for your company. Some people might get into the bad habit of just copy pasting AI generated text and forwarding it along, but it's really important to make sure that you read through what it is that you're sending along or essentially shipping as yourself. This is something you generated with your name on it. You want to make sure that the data is good and it makes sense. But I think this gets you 90% of the way there. And something really cool too is if you start at a new employer or if you're auditing a new network, you can run this tool and instantly say to your manager, hey, here's the top 11 findings and flags that I found in our network that are potential issues, and we should probably look at these soon. So our workflow is done. You have a finished runbook, but I built one more thing that I think you'll really like. So this basically will take the runbook that we created, parse out the data, put it into an XML format, and then give it to you in a draw.io diagram. So let me show you. So we'll do Python. So here's the output from the script. Found 3 devices, 2 links. Save the diagram to this location. This script specifically reads the CDP neighbor data and the interface IP addresses, and then generates a draw.io network diagram. There's no AI involved in this. This is just simply a Python script that takes our runbook and puts it into an XML file. This runs entirely on your machine, so there's no redacting required on this step. We'll just simply open draw.io. We'll open a new diagram. We'll browse to the output folder that has all of our artifacts. And here's the network diagram. So this, again, shows the edge router, the core router, the access switch. This will show the interfaces on both sides, the IP addresses if it does have an IP address. And if you've never used draw.io before, this is just a starting point. So you can take and you can drag these around. You can edit this diagram however you want. You can export this into many different file formats. So you can export as a PNG, a JPEG, a PDF. You can create a Visio diagram off of this if you use Visio. This is just a starting point for you. And yeah, this is a super basic diagram, but I think you get the idea and the power that this could have on a real environment. As I said previously, all 5 of these scripts are on my GitHub. You can download them, point them at your own lab environment, or even at your own production environment. And if you want to mimic my exact lab, there's even a YAML file in my GitHub that you can download and just import directly into CML so that all of your network devices are configured for you and you're ready to go. If you don't have a single source of truth yet, like a netbox or an Autobot, this is a great stopgap. And if you do have a single source of truth, this only gets better from there. The next video takes us a step further. Instead of copy pasting data into an LLM, we wire the whole thing up to an API. It's one command, start to finish, and I'll have a link to that video up here. Let's recap what we just did. First, we collected raw show command output from live network devices using Netmiko. Second, we redacted sensitive information like serial numbers, host names, MAC addresses, IP addresses, everything, so it's safe to hand to an AI. Third, we assembled a structured prompt and pasted it into ChatGPT 5.4 extended thinking and got back a complete operational runbook. Fourth, we restored all real values back into that runbook. And then we generated a network diagram using draw.io of which no AI was needed for. That's a full documentation refresh in about 10 minutes. Run this quarterly. You can run this every time you make a change. You can run this against a new network that you're discovering for the first time. There's many uses for it. So how are you handling network documentation right now? Are you writing it manually? Are you using a wiki? Do you actually have a single source of truth that you're generating these from? Drop it in the comments. I'm genuinely curious what everybody's approach is. If you got value from this, I encourage you to subscribe and like the video. It does help me out a lot. I drop practical content like this pretty frequently on my YouTube as well as on my LinkedIn and GitHub. Thanks for watching, and I'll see you in the next one.